Hello and good day, everyone. Welcome back to my YouTube channel. This is Sir Marcy, and for today's topic, we're going to discuss solving direct variation problem. Okay, before we go directly to our main topic, let's try to recall first our previous lesson. First is you're going to transform the following statement to mathematical equation. I'm going to give you only 15 seconds to answer this. Timer starts now. All right, time's up. In number one, the answer is capital W is equal to Km. In number two, capital D is equal to Ks. Number three, capital L is equal to Kh. Number four, capital C is equal to Kn. And number five, capital B is equal to Kh. If your answers are all correct, then you are great. In our previous lesson, we discussed also how to find the equation of variation. Let's say we're going to find the equation of variation where y varies directly as x when y is equal to 48 and x is equal to 6. Step number 1 is we're going to use the equation y is equal to kx. Next is we're going to find the value of k when x is equal to 6 and y is equal to 48. Next is, we're going to divide both sides of the equation by 6. And lastly, if after dividing it by 6, we now have the value of our k, which is the constant of variation. That is equal to 8. Then we're going to substitute this to write now our equation of variation. That is now y is equal to 8x. Let's have another example. Find the equation of variation where y varies directly as x when y is equal to 10 and x is equal to 24. So use the same equation, y is equal to kx. Next is we're going to solve for the value of k when x is equal to 24 and y is equal to 10. Then, we divide it both sides by 24. So, 10 is equal to k times 24 divided by 24. Our value for k is equal to 10 all over 24, which we know that this is still reducible to lowest term. And the value of our k now is equal to 5 all over 12. Our equation of variation now is y is equal to 5 over 12 times x. Here are the steps in solving direct variation problem. Step number 1, write the correct equation. Direct variation problems are solved using the equation y is equal to kx. When dealing with word problems, you should consider using variables other than x and y. You should use variables that are relevant to the problem being solved. Also, read the problem carefully to determine if there are any other changes in the direct variation equation, such as squares, cubes, or square roots. Step number 2, use the information given in the problem to find the value of k, which is called the constant of variation or the constant of proportionality. Number 3, rewrite the equation from step 1, substituting in the value of k found in step 2. Number 4, use the equation found in step 3 and the remaining information given in the problem to answer the questions asked. When solving word problems, remember to include the units in your final answer. Okay, let's try to have example number 1. If y varies directly as x and y is equal to 15 when x is equal to 3, find y when x is equal to 5. Step number 1, we write the correct equation. In this problem, we have y varies directly as x. If we will translate this to mathematical equation, that is y is equal to kx. Next step is you're going to use the information given in the problem to find the value of k. In this case, you need to find k when x is equal to 3 and y is equal to 15. So we divide both sides of the equation by 3. So 15 divided by 3 k now is equal to 5. Then step number 3, rewrite the equation from step 1, substituting in the value of k found in step 2. So from y is equal to kx, that is now y is equal to 5x, since the value of k here is 5. Next is we're going to use the equation found in step 3 and the remaining information given in the problem to answer the questions asked. In this case, you need to find y when x is equal to 5. So from y is equal to 5x, we plug in the value of x, which is 5. So y is equal to 5 times 5, then the value of y is equal to 25. Okay, let's proceed with example number 2. If x varies directly as y and x is equal to 9 when y is equal to 3, find x when y is equal to 12. First step is we're going to write the correct equation. In this problem, it states that x varies directly as y. If we will translate this to mathematical equation, that is x is equal to ky. Step number 2, use the information given in the problem to find the value of k. In this case, you need to find k when x is equal to 9 and y is equal to 3. So we have 9 is equal to k multiplied to 3. So divide it both sides by 3, and 9 divided by 3, k is now equal to positive 3. Step number 3, rewrite the equation from step 1, substituting in the value of k found in step 2. So from x is equal to ky, that is now x is equal to 3y. Step number 4, use the equation found in step 3 and the remaining information given in the problem to answer the question asked. In this case, you need to find x when y is equal to 12. So from x is equal to 3y, we plug in the value of y, which is now equal to 3. So x is equal to 3 times 12, and the value of x is equal to 36. Let's proceed with example number 3. The distance d a body falls from rest varies directly as the square of the time t it falls, ignoring air resistance. If a ball falls 144 feet in 3 seconds, how far will the ball fall in 7 seconds? Step number 1, write the correct equation. So the equation here is the distance d a body falls from rest varies directly as the square of the time t. That is, capital D is equal to kt squared. Step number 2 is we're going to solve for the value of k. In this case, you need to find k when d is equal to 144 and t is equal to 3. So we have 144 is equal to k times 3 squared. If we're going to expand it, that's now 144 is equal to k times 9. Divide it both sides by 9 to solve for k, and the value of k here is equal to 16. Step number 3, rewrite the equation from step 1, substituting in the value of k found in step 2. So we now have capital D is equal to kt squared. That is now capital D is equal to 16t squared. Last step is we're going to use the equation found in step 3 and the remaining information given in the problem to answer the questions asked. In this case, you need to find capital or D when t is equal to 7. So capital D is equal to 16t squared. That is, capital D is equal to 16 times 7 squared. Expanding it, we now have 16 times 49, and D is equal to 784 feet.